of the application security practice at TrustWave, and David works for me on my team. We're here today. This is a presentation we've now done at a couple of conferences, and a lot of people always ask us, where did the name come from, and want a little background on really sort of what's, in our opinion, kind of a nifty name. It actually stems from a happy hour we had after Black Hat a couple years back. And we were discussing a particular client engagement. And we'd actually gone into an application penetration test. And the client had told us, oh, really, I don't even know why you're here. This application doesn't need testing. We've been scanning it with automated tools, and we have a WAF in front of it. Our management is making us do this. We really don't think it's necessary. And we completely compromised the application very, very badly. And at the end of the engagement, we presented the findings, and the client thought that the whole thing was impossible. How could you bypass the WAF? How could our automated tools have not detected this? And at the happy hour, it was a team-only discussion, and we were discussing ways that we could actually communicate to the client how these kinds of things happen, because we see them a lot. And one of our colleagues, who probably had a bit to drink, actually said, well, you really can't filter the stupid. And the phrase kind of caught on, and we've even made t-shirts with it, and we think it's very apt. And this presentation really deals with just that you can't filter the stupid. And there's some things that automated tools maybe aren't quite cut out for. And before we go any further, I'd like to also say that the stupid, we're not referring to people, we're not calling people stupid. It's a finding that is usually kind of funny, but more than that, it's very serious. It's critically dangerous, and everyone makes mistakes. So certainly we're laughing with the developers, not at them. So if we look at this picture here, and David, if you could give me a little bit of room, we have a fence at the airport. You can see the tower back there, and this gate that we have here is nice. It's 8 feet tall, razor wire at the top. It's very secure, and it's a deterrent for trespassing. The problem is that we're not always looking at the whole picture when we see things like this, because sometimes there are key components missing. As you can see, this gate is very well constructed, but there's actually no fence on either side of it. And this individual here is actually driven around it. And the same problem often leads to some of the most devastating application compromises. We're not looking at the whole picture. And centralized security controls are always appealing because they can reduce work, they make things easy, and there's just one central point. But if you're not looking at the whole picture, you can often miss very critical holes. And again, if you allow people to just drive around, your gate's fairly worthless. Now, at the URL at the top, we have sort of an analogous flaw. We have an application flaw where all the pages within this application are actually requested through main.php. However, the pages are actually stored in the web root, so you can just request the pages directly. And main PHP controls authorization and authentication. If you just request them directly, there's no authentication, no authorization. You can get to all the application without any kind of security control. Again, just like the gate.
So just to be clear, we're not trying to say that automated security solutions are worthless at all. We're trying to point out some of the key critical deficiencies in them, but there are certainly a lot of strengths as well. If I was running a web application or a security group in general, an IT security group like I used to, I would want to have all of these offerings in my arsenal. Each one of them can have a very important role in a broader scope of application security. TrustWave offers a number of these products ourselves.
And actually, for those in the audience that might be familiar with Breach, the firewall vendor, we actually announced their acquisition, I guess it was yesterday. And so we're certainly not running down automated technologies. We believe in them strongly as well as a piece of the puzzle. We're just saying that they're not necessarily the silver bullet.
Some of the advantages that automated tools can offer include a low incremental cost. It's a lot cheaper to train someone to use an automated tool compared to the years that it takes for a penetration tester to become an expert in the field. It also can, solutions like a web application firewall or an intrusion prevention can offer 24/7 protection. WAFs also make it possible to provide a temporary quick solution or a quick workaround for a vulnerability. So a lot of times it takes developers a while to code and then fully test a patch for a vulnerability when it's discovered. Where it's very easy, though, to create a new rule for a web app firewall, push it out to temporarily stop or at least inhibit the exploitation of a new vulnerability.
And contrary to what security marketing departments have told us, automated tools miss a broad array of issues from several vulnerability areas, ranging from the practical to the theoretical.
I've spent a lot of time writing some automated security software myself, and when I was working on one of these projects, my wife, who used to be an interpreter, made a very good comparison between automated security solutions and automated translation software. I think most people here probably use Google Translate or Babelfish, something along those lines. And while those products work pretty well, they certainly haven't put human translators out of business. There's some information that you really need to have a human look at. For example, a document that is very sensitive to the precise meaning, such as a legal document or maybe a medical text. Or something where the nuances of human language are very complicated, like a poem or a piece of literature. You would never want an automated software to translate that. Sometimes when you use automated software, you get a pretty good result for something simple, but sometimes you also get something like this. And if you can't see it, it says translate server error when it should be reading just restaurant. Apparently they used some automated software, it didn't work so well. It's a good example of a sort of a worst case scenario for relying on software. Penetration tests, though, aren't a perfect solution by any means. There are some things that you really can only discover with a code review, or at least it's easier to discover. Something that might take hours and hours to finally find within a manual penetration test, you might be able to find in a matter of minutes in a code review.
And you know, some people might respond to that with, well, great, but who's looking at my code? If it can only be found with the code review, I've got nothing to worry about because my code is private. There are a number of source code disclosure possibilities. I'm not going to read through these. I hate it when people read through slides, but baseline is security through obscurity is always a bad idea. If you're relying on the fact that your source code is private, you've got problems. And I'm sure if we sat here and brainstormed, we could come up with another 20 ways that source code could be disclosed.
So all the examples that we're using in this presentation are real vulnerabilities that were discovered. These are all vulnerabilities that could not be found with an automated tool for one reason or another. There's a lot of different categories that these can be broken into, and this is obviously not an exhaustive list of categories, but some highlights of things that we frequently see during manual penetration tests or code reviews that we perform. The majority of these are from actual tests that TrustWave did. Obviously, we've sanitized our clients' information. Confidentiality is very important to us, but the core vulnerability is still true. There's some that were taken from public sources, so we didn't make an effort to hide identities there since it's well known anyway.
And this is actually one of those public sources. If you can see here, Two-Tone Inc. will be closed Thursday and Friday. And what this actually stems from is there was a web forum that allowed people in South Carolina, business owners and school administrators, to announce inclement weather closings. That is, bad weather's happening, just fill out this form, and in 5 minutes you can read whatever you put on TV. The problem was there was actually no one reading these inclement weather warnings, and late one evening someone discovered this and posted it on a web forum, and within literally minutes there was a deluge of fake inclement weather postings. And Most of them were really funny, actually, and nearly all were not fit for television. And unfortunately, these two were the only ones that were fit for this audience. Just my professional reputation, tarnished as it may be, I couldn't put the really funny ones on here, but you can search in Google, they're really good. But as you can see, Haxord Computer Services Inc. will open at noon tomorrow. Check website for details.
This is from a penetration test that we did against a rather specialized search engine. One of the features that it had was that a website owner could go to the search engine, submit the URL to their site, and the site would very quickly the search engine would very quickly spider the website and post the details on their web page. Now, what we discovered during the penetration test was that they did not have any limits on what could be spidered. As a result, an attacker could go in and say spider localhost or spider private IP address space and basically explore all of the websites on the company's internal network. And if this had been exploited in production, the results would have been posted to the internet for everyone to see. And it could even have been leveraged to attack and exploit certain types of vulnerabilities on our client's internal network. Fortunately, it never actually happened. Just another example of something that you couldn't find with an automated tool. This wasn't actually from a web application. It was from a thick client that used a web service, so it's still pretty closely related to OWASP topics. The very first thing that the application did when it was started up was send an HTTP request to the web service. The main body of this was a string of characters, hex encoded obviously, and when we decoded it, it was random data. It didn't appear to be compressed, didn't have any compression headers that we could identify, so we deduced that it was encrypted. The problem was there was never any key exchange. This was encrypted within the packet. It wasn't using SSL or anything like that. Since there wasn't any key exchange, we knew that it had to be using a static key, which is very insecure. So we started looking through the application, loaded it into a debugger, and traced the execution until we found a SQL query in the memory. And what it was doing is basically querying the database server through the web services interface to check if the product was properly licensed. It's pretty easy at that point to modify the query so that basically we just started exploring the database schema, and when the execution of the client was resumed, the query that we had substituted was encrypted, sent to the web server, and the response was very nicely encoded in an XML format where we got all the listed tables and columns, and eventually we were able to extract credit card numbers from the database as well. This is an example of a design flaw that comes from a pen test against a restaurant's website. The website was pretty simple and straightforward. Basically, you could order delivery. Just tell them what you want, give them your address, make the payment. A little bit later, your food comes. Like a lot of online merchants, they had decided to have a third party handle their credit card transactions. A lot of advantages from that, doing that, both from a security point of view and especially from a compliance point of view, but they didn't implement it properly. What happened was the restaurant's website would send the price as a hidden field along to the payment processor, but there was no kind of tamper detection built in. As a result, an attacker could very easily change that value to, say, just a few cents instead of the full price of the item. And as long as that small amount was paid with a credit card, the payment processor would send back a cryptographically signed authorization code saying, yes, this is a valid transaction, it was approved, but there's no amount in there. So the restaurant would naively accept it and process the order. It turns out in talking to the developers that basically the restaurant developers had assumed that the payment processor was providing